Okay, I think we can start. Asluf, you can start.
Yeah, sure. So, hey everyone, welcome to the bi-monthly tech session by Efito Solutions. So, in from this session, in this 1 hour period, we'll be diving into the introduction session to AWS services. So, our target audience is mostly the beginners of the uh, into the and AWS services. So this entire session will be delivered by me, myself, and Asluf, Ansala, and Diveshkar. Can you go to the next slide, please? Yeah. So today the content of this session is we will be talking about what is AWS Cloud and what are the essential AWS services we can use as beginners or any intermediate uh, person coming to the cloud environment. Then in first 30 minutes of this session, we'll be talking about more into the more concept level services in AWS uh, and what we can do with those services. Then in the next 30 minutes of the session, we will walk through a real world use case uh, and then we will show you how to implement that use case using available services in AWS. Then after that, we will be demoing the solution for you in a demo environment. So yeah, that's going to be the presentation in this session. Yeah, can I go to the next slide? Yeah. I believe most of us here are coming from maybe from different cloud backgrounds, maybe first time seeing this AWS cloud related services. So if I brief you what is AWS and what is AWS Cloud. So AWS is an entire cloud ecosystem which has more than 200 plus services readily available for your use cases. So if you can see this figure, so this is like entire cloud services are available in AWS. So if you take an example like a database, so in the database layer, you can see like services like DynamoDB, then RDS. So mainly the RDS is the SQL database in AWS cloud environment. Then DynamoDB is the NoSQL database in AWS. Likewise, you can see different services under each section. So like if you take an example like EKS. So that's stand for Elastic Kubernetes Service. So it's under compute engine, compute part. Then if you take a service like Elastic Beanstalk, EC2, Lambda, it's again in the compute part, as you can see from this diagram. So likewise, there are a lot of services readily available in AWS cloud environment. Based on your use case, you can choose whatever the service you need for your task. Like if you take an example, like I want a storage to store my media files or the any files, so we can use S3 in the AWS. Likewise, this is like an entire ecosystem. So we have so many services we can readily available for our usage. Yeah. Can you go to next slide? Yeah. So in this session, our team will be diving into these 5 services. So we thought of going deep into these services in this session because we believe for any project or any system, these services are essential. So, so, uh, if I brief you what is AWS and what is AWS Cloud. So AWS is an entire cloud ecosystem which has more than 200 plus services readily available for your use cases. So if you take an example like if you take a service like Elastic Beanstalk, EC2, Lambda, it's again in the compute engine, compute part. Then if you take a from here onwards, I'm handing over the presentation to Ansala, so he will continue from here onwards.
Okay, so I will explore two AWS services, Amazon S3 and CloudFront. Let's start with Amazon S3 or simple storage service. So S3 is an object storage service. You can store and retrieve any amount of data from anywhere, and it's fully managed. It means AWS handles the infrastructure, scalability, and availability for you. So you can just focus on your data. This service is highly scalable. So you can store an unlimited amount of data using S3. And unlike traditional file storage, S3 stores data as object inside buckets. Understanding S3 buckets, a bucket in S3 is like a top-level container where you can store any kind of objects which are essentially files. And also you can host a static website using S3. And when talk about buckets, each bucket has a globally unique name and is region specific. So when you create the bucket, you need to choose an AWS region where your bucket resides. This tree structure is flat, meaning there is no nested folders. There's objects within buckets. And using AWS Management Console, you can easily create a S3 bucket. And to interact with the Amazon S3, you can use AWS CLI for command line operations and AWS DK for programmatic access within applications, and the AWS console as the graphical user interface. Yeah, so that was just some general background information of S3. And let's move on to the storage classes. Can you go to the next slide? So S3 offers various storage classes to optimize cost and performance based on your data access patterns. By default, all objects uploaded to S3 bucket are stored in the standard storage class. So according to your use case, you can change the storage class using AWS DK or console. For example, if you have frequently accessed data, you can select the standard class. And if you have backup and archive data that is rarely accessed, you can just select the glacier class. Then let's talk about versioning and lifecycle policies. Can you provide so? So you can set lifecycle policies to automatically move objects between storage classes or delete them after a certain period. For example, if you want to change your storage class to Glacier after 30 days, you can define it in the lifecycle policies using AWS console as shown in the picture. And also S3 support versioning, which allows you to keep multiple versions of the same object. So if you accidentally delete the file, you can restore previous version. Yeah, let's move on to the security and access control. So security is a top priority with S3. By default, S3 buckets are private, so only authorized users can access the bucket and its objects, but you can make them public according to a use case. You can define who can access your buckets using IAM policies, bucket policies, and access control lists. IAM is Identify, Access, and Management. It's also a service that provided by AWS. So that allows you to create and manage users, roles, and permissions within AWS. So we can define IAM policies to control who can access S3 bucket and what access they can perform. You can define those policies using AWS Management Console as shown in the picture or using AWS SDK. And also S3 offers server-side encryption and client-side encryption for data protection. That's about it in terms of security. This we can talk about AWS Software Development Kit for Amazon S3. Using AWS SDK, developers can interact with the AWS services programmatically using various programming languages. As an example, in here I put some JavaScript code snippets that include S3 bucket operations like uploading, downloading, and deleting objects in S3. So, you can get familiar with the AWS SDK by going through the AWS documentation, which offers examples for each operations in a variety of programming languages. Using SDK, you can integrate those AWS services to your software application. Now let's move on to the AWS CloudFront. So CloudFront, the fast and highly secure content delivery network. So using CloudFront, you can access data with low latency and high speed. It works by caching content at edge locations. Edge locations means nearest data centers to the user. This ensures that user requests are served quickly from the nearest location. If the content isn't cached in the nearest location, CloudFront fetches it from the origin, such as S3 or EC2, and caches it for future requests. And that's how the CloudFront works. And if you access the S3 bucket directly to retrieve objects, you may experience some latency. So it's better to use the CloudFront to access S3 objects. Is a recommended way. And you can easily create a CloudFront distribution using AWS Management Console. And also you can seamlessly integrate CloudFront with Amazon S3, Amazon EC2, and AWS Lambda T, AWS Shield, and AWS WF. Yeah, these are some basic things you need to know about AWS S3 and CloudFront. Yeah, next Diveshkar will explain about Lambda functions and API gateways. Diveshkar.
Okay, thank you, Ansala. Okay, hi all. Today I will be presenting the AWS Lambda and API Gateway in a simple and engaging way using real-world example. So let's start by understanding the AWS Lambda. If you look into the AWS Lambda AWS Lambda is a serverless function. Uh, it's like a commuting service. So it's fully managed by the AWS. If you want to run this code while responding to events, so you don't need to want to any infrastructure or anything. You just want to go and create the function and write the code only for the deploy it. You don't want to worry about the infrastructure or anything. And if you look into the and also you have to before go through the lambda function, you have to know it's a one demand function. It means that when your requirement is this function is no need to run this server is no need to run always. In that time you can able to prefer the lambda function because when it's call only this lambda function will be running. That's the thing in here lambda. And before and this lambda function is short time execution because its maximum timeout is only 15 minutes. So we have to you have to consider about that your requirements also. So if we go through the key feature, it's I already told about this one. We you don't need to manage any infrastructure, so we can able to say as a serverless. And when you want to execute the code, we can trigger by the events we can able to execute, such as a API request or file upload, like that thing. And if any, how many traffics if it is come also he can able to it can handle by traffic also, so it's auto scaling also. And main thing is it will be support the all of the popular language, like you can works with Python, Java, Node.js, and Go, and Ruby also, like that language, which are the language you can able to use it and write the code and deploy it. That's the thing you want to do it. And we can able to trigger the lambda function if any files come into the S3 bucket also. In that time you have to notice that S3 bucket uh, S3 bucket region also. If it's a lambda function is another region and S3 bucket is another region, you want to use any another message service you have with using Tamai, you can able to connect it. Otherwise, if you use same region of the lambda and same region of the S3 bucket, you don't need to you don't need to extra any services. You can able to connect with directly. And let's go through the real world example in the lambda function. Let's think you want a user has to upload the file, like that file processing like that, you can able to write the code with any kind of language, Python, Java, Node.js, like that. You can use to any packages and write the code, and you and that time Lambda extract the text from that file and store into the database, like that thing you can use with Lambda. And image processing, like let think you user want to upload the profile, like that time you can, I already told, you can use any languages and you can use the packages, and uh, we can trigger the Lambda. From the Lambda we can generate the thumbnail and high resolution image, like that thing. And if we consider about the business side, let's think you want to CSV reports, like via email, like that thing, then Lambda can help to format the CSV report and save into the storage and give it to the user, like that thing. And let's think you want, if you think the e-commerce site, um, the pizza delivery, like that thing, um, if anything order placed, order confirmation, like that, we can able to trigger the Lambda, send for the SMS or email notification for that placed order, like that thing. I think you something got about the Lambda. So from here I am jumping to the API gateway. Okay. If we go through the API gateway, API gateway also fully managed service with create the API and deploy it, that manage the API, like that thing. If you deeper understanding, you can think like that. This API gateway is act as a bridge with between the client and backend services. Like that, we can use a entry point into API gateway. We can communicate with multiple API endpoints, like that thing can happen by API gateway. Like if you go for API gateway key features, it's like multiple API types. They are included, like a REST API, HTTP API, and WebSocket API. In WebSocket API using, you can able to send the notification from front end, like that thing. And it managing the security and access control also. It's mostly supporting the IAM control service and Cognito service. Both are in the AWS service, another part, and auth service also, and JWT token authentication also it's using. And in here API gateway also controlling the limiting of the API usage, like throttling, like rate limiting, like that. And this also can able to scalable the based on the demand. And if we go for the real world use cases, let's think mobile app want to fetch the user profile from the backend. So we can use the API gateway and fetch from that database, like that. If you think the Uber or pick me, like that thing, we have a multiple, we want to communicate with multiple API, like the driver, passenger, payments, like that. We can use the API gateway and communicate with that all of the API. And it providing the authentication security, like that thing also. We can use by JWT token and auth, like that authentication. We can able to restrict that access also. And a single user want to preventing the excessive API. This also, by using API gateway, we can able to uh, use it by we can reduce the backend load, like that thing. I think, and after that, if we uh, if we use AWS Lambda and API gateway, if we blending with them and use it, you can able to create the scalable and secure and cost efficient serverless most powerful applications. You can able to create it. And I think you got it something about API gateway, right? So from this, I'm handovering this session to Prathumaya to continue the Elastic Beans session. Thank you all. Thank you for your time.
Sure. Thanks, Desh. So let's talk about Elastic Beanstalk. Yeah. So most of the time, when we have to deploy some web application or API service, we have to worry about our infrastructure, then the configuration settings is correct or wrong, and whether it's can be auto scale about load balancing likewise. So in AWS, they give a entire service called platform as a service called Elastic Beanstalk. So which simplifies the way we deploy and managing the web applications and services in AWS cloud. So basically, it's supporting multiple programming languages like Java, Python, Node.js, PHP, .NET, etc. So so how to set up this Elastic Beanstalk? So there's two different ways to set up this Elastic Beanstalk in AWS environment. We can directly go to the AWS dashboard. Then we can zip our code and we can upload it to the application as a zip file. Then we can choose whether it's a Node.js project or any Python project. We can choose the platform to install with this application. And also at the same time, we can configure environment like how many instances we need to run this application, how our database connections work, our security groups work, how the auto scaling can be work here, likewise. Then with a single click, we can easily deploy our entire application in a few minutes time. And the next part is we can use AWS management console. We called it Elastic Beanstalk CLI, EBCLI, in order to deploy our application from CLI. So for that, we have basically made 3 commands. Like we can initialize our repository using init command. From that one, we can initialize our repository. Then from create command, we can configure our instances, database, security, like the configuration environment for our application to run. Then from deploy command, we can easily deploy the things into the AWS. So the main advantage of this Elastic Beanstalk is we can configure all our environment settings like instances, database, security in our code base itself as in the code base itself as a configuration file, configuration YAML file. So when deploying things, the Elastic Beanstalk will handle the entire environment. So if you take this as what are the key use cases in this Elastic Beanstalk? So mainly this is using for web application hosting. Then also we can use this for the microservices and APIs hosting also. And mainly we can use this again for DevOps and continuous deployment. Then if we have a prototype or any MVP that need to rapidly launch, we can use this to rapidly launch any kind of application. So when it comes to this figure, you can see like this is called Elastic Beanstalk environment. So inside Elastic Beanstalk environment, there we can configure the any available services from AWS. Like inside Elastic Beanstalk environment, you can see we can put a Elastic Load Balancer, and we can configure any any number of EC2 instances under Elastic Beanstalk. Assume like if we have like 4 app stores, like one is from React, one is from Angular, one is from Node.js, one is from Fast API, likewise. So in this scenario, we can directly use Elastic Beanstalk, and we can separately host those 4 applications in different EC2 instances like this figure. So then we can add the auto scaling group, then load balancing part, security part on top of this environment. Then we can, if we need any database connection or any S3 bucket connection, we can directly use those services as well. So that's the main advantage of using an environment like Elastic Beanstalk, because it has all the readily available services that is available for our entire deployment part, and also the managing part, because it's much easier for everyone to deploy and manage any kind of web application. All the things are under infrastructure, and everything is handled by Elastic Beanstalk itself. So That's mainly about the services. First we talk about S3, then CloudFront, then Lambda, API gateways, Elastic Beanstalk, likewise. So we thought of talking about these five main services as in the first part because we thought that is like mostly used and most essential for any kind of software project. So from here onwards, we will be diving into a real world use case and we will be showing how we can use AWS services to solution architect that use case. Then we will be demoing how we can use AWS services to solve that solution in the AWS environment. Yeah. So from here onwards, I'm handing over the presentation to Asluf.
Yeah, thank you. Let's see some real-world use cases of AWS services. Here, I took a small scenario to explain and give the solution for that using AWS service. Many modern web applications require users to upload and process large files such as PDFs containing floor plans, blueprints, or detailed any documents. These files can be hundreds of megabytes in size and often contain multiple pages as well. The challenges is to efficiently process, store and serve these files without impacting the performance and user experience. So just think like if we upload a PDF with several pages or else several PDFs with several pages, and we need to generate SVG and thumbnail for each page. That's our example use case. You all can remember this. I can tell again. Just think like if we upload a PDF with several pages or else several PDF with several pages, and we need to generate SVG and thumbnail for each page. That's our example use case. You all can remember this. So if file uploads and processing were handled entirely on the client side, I mean in the web browser, I mean in the website implemented by React or Angular or anything, that approach led to several critical issues. Like high processing and memory usage since file conversion was done on the client side. It will consume significant CPU and RAM resources, and also a long processing time and lack of user experience will be there, and also scalability challenges issues can occur for surely. As more users upload large files, system performance will be degraded as well. So these are the main problems can occur if there is no any well-structured architecture to handle the process. So let's see how to give a solution for this using AWS. To solve these problems, we need a scalable, efficient and serverless approach. So AWS is one of the best solution for this scenario. To address these challenges, we can implement a serverless AWS-based architecture that can provide high scalability, efficiency and security. Here is how it works. I will explain. As you can see, this is the client. I mean, for example, I put as Angular or else React or anything, any kind of client. So our task, our requirement is to upload a PDF file, and each page will be converted, should be converted to SVG and thumbnail and store in the S3 bucket, and also for the reference, the URLs or other metadata can be stored in a separate database, MongoDB or something. So for that kind of scenario, we have implemented two Lambda and two gateways, so that and the S3 bucket and also CloudFront CDN is there. From the client side, first of all, to upload the file, we need a pre-signed URL for the security reasons. For that one, we can call the created API gateway and get the pre-signed URL using the Lambda that integrated with the API gateway. It will return the pre-signed URL. From that pre-signed URL, we can send the files. I mean, we can upload the files. We can upload any objects to the S3 bucket itself. Whenever the upload is finished, then we can set up a small configuration like triggering a lambda function like an event. Whenever the upload is finished, we can trigger that this lambda, the lambda we have created. It has the main logic for generating SVGs and thumbnails, so that this triggered function will be working, and it will run and it will generate thumbnails, and it will generate SVGs, and it has the logic to store again in the S3 bucket. So this lambda will do all the works. While doing, after it has done, in the last step, we can store all the metadata kind of thing, URL of the stored images and all the things in the MongoDB or else other kind of databases that we have created. So simply we can call a HTTP request or any kind of request to store the things. At that time, client will face a small issue, not a issue, actually small kind of time, so that for that we can show a progress bar. To show the progress bar as an example, we can create a socket connection to show the progress. I mean, kind of percentage 10, 20, 90 and 100 like that. Something we can show the progress while the lambda is working. Whenever it's loading, we can show the progress, calculate the progress, and we can send it to client. And in the client side, we can show the progress bar. So that kind of scenario we can implement for this problem. So the last part is CloudFront. CloudFront is, as Ansala explained in the previous slide, it's a it's a content delivery network that is most efficient with S3 bucket for fetching the files to the client side. So with this architecture, we can successfully offload heavy processing from the client, significantly improving performance and reducing processing time and enhancing the security. AWS enables us to handle a large file uploads as well with an efficient manner, while keeping our application scalable, responsive, and cost effective. So that is the solution for the predefined problem we have told in the previous slide. So let's move into the demo part. Yeah, this is the AWS console dashboard after you have successfully completed your registration and login. You will be redirected to this dashboard. Normally we can search the things here if there is no any things in the recently visited. I have visited before, that's why it's showing here. First of all, we can see how to create the create S3 bucket and connect that S3 bucket with the CloudFront. It means the CDN that we have discussed before. Here we can easily click here, or else we can search S3 here and we can click here. Then we will be moved into the S3 buckets. Yeah, here I have already created 2 buckets, that's why it's showing here. We can easily create a bucket by clicking this button, and then we can give a name to this one. Tech session test. Yeah, it should not have any capital letters. The bucket name should not have any capital letters. Then we can move to downside, all are default ones, and yeah, we can create a bucket. This is a different name and try again. Yeah, we can create a bucket name, tech session test 3. Yeah, it's created now. This is the bucket, and here manually we can upload any objects by clicking this button or this button. Just I will add a small one, add file and user.png, upload. Then it will be uploaded. I just uploaded a small image to check, and yeah, that's how we can create the S3 bucket easily. And then we can see how to create the CloudFront and connect that CloudFront with this S3 bucket. The S3 bucket name is text session test3. You can remember a little. Again, if we need to move to other dashboards, we can easily search here, or else we can click the AWS button and we can go to dashboard and come back. I'm going here by searching CloudFront. Yeah, here you can see the already created CD and distributions. I have created the one before. If we need to create a new one, we can click here, create distribution, and choose the origin. Yeah, this is the buckets we have created already. Here you can select, this is the bucket that I have created recently, text session test3. We can choose that, and it's default they are giving public access. We can change that to recommended one, access origin control setting, and we can create a new OIC by just create for the recommended one, and then we can move to downside, all are default. And here some additional settings are there. Yeah, all other things are default. Yeah, we can easily create distribution here. Yeah, after creation it will take 3 to 5 minutes to deploy these settings that we have created now. Until that, we can do some small configurations. We can copy this policy button, copy, and we can move to this link. I mean, this one we need to do because the CloudFront should access our S3 bucket that we have created. So that we need to set up the policy. I mean, both are different things. It means the CloudFront and S3, we need to create a connection between the CloudFront and the S3. So we need to put a policy in the S3 bucket. So that we have copied here, and we need to go to this link. Yeah, it's going to our bucket. This is the bucket we have created. In the bucket, it's coming automatically to permission tab, and in that there is a bucket policy. We can edit it. By default, the policy will be empty. We can paste the copied policy here. The reason behind setting the policy is to enable the access of S3 bucket to the particular CloudFront platform that we have already created now. It's telling this is the URL of that bucket we have created. We are just telling that enabling access. That's why we are creating a policy, and just save changes. Yeah, after creating the CloudFront, we need to set up the policy to access the S3 bucket. Yeah, that's all. From the S3 end, we can see the deployment status. Still it's deploying. After deploying completed, it means it will show it should show a date and time that the last modified. Then we can continue that. It will take a little time. Yeah, we can wait a little. the deploying is finished now successfully. Now we need to check that the CloudFront is created successfully. To check that one, we can copy the URL. This is the URL of this CloudFront distribution. We can copy this one and we can paste in the tab and put a slash n. You maybe remember that I have uploaded an object here called user.png inside the bucket. So put a slash n, we can enter this user.png. Then like this we can ensure that the CloudFront is established successfully. And this is how we can create the S3 bucket and create the CloudFront distribution and connect those two. Now I will walk through how to create an AWS Lambda function and set up an API gateway and connect the Lambda function with the API gateway together. So there are 3 steps. First step is to create an AWS Lambda function, and the second step is to set up a API gateway, and the third step is the step which connecting the Lambda function with the API gateway. So in the first step we can go to create the Lambda function. Just we can search here, or else we can click that one, Lambda. We are going to create a new Lambda function. Yeah, easily click by the create function button. Can give a name, my Lambda, and after that we can select the environment of the Lambda function we are going to create. There are more environment available: Node.js, Java, .NET, Python, and most of them are there. In that one I am just selecting the Python, and there are more advanced settings. I am leaving it as default for now. And now the Lambda function is creating. In the Lambda function, once the Lambda function is created, we can code it. I mean, we can implement the functionality inside the Lambda function. Yeah. Code editor is there, so I'm just editing a small different. Hello, like this I'm doing. This is a small comment. Yeah. After doing changes in the coding, we can just deploy it. First of all, I forgot to tell, this is the Lambda function, how it looks. This is the Lambda handler. Inside this one we can develop anything. Just we can put, if this is in Python, we need to do in Python. If we selected Node.js, we can continue the development in Node.js. Yeah, it will be going like this. After doing any changes, we can deploy it. Deploying message will be shown in the downside. After deploying, we can test it here also by clicking the test. We have to create a test event, test 3, and just save it and click the test button. Yeah, click the details, then we can see the response from that function. Hello, Efito from Lambda. This is the function. This is the return message we are getting from that Lambda function. Yeah. Now we can move to the step 2, setting up the API gateway. Here we can easily search the API gateway by this API gateway and go inside. First step is finished, that we created the Lambda function. second we are going to create a API gateway, then only we can access the Lambda function. So inside the gateway, this one I have already created, new one I need to create. There are more types of API gateways available: HTTP API, WebSocket API, REST API, REST API private also there. If you need a WebSocket kind of thing, we can build it here. Now I need a REST API, like get method one, just to call the Lambda function that we have created. So I'm clicking the build here. So API name, just I'm typing get my Lambda, and it's already, yeah, new API, yeah, leaving it as default. Other things are in here. Yeah, the thing is created. After that we need to create the method. This is the gateway that's just created only. We didn't connect the Lambda functions yet. Now we need to create the method. Inside the create method we can connect the Lambda. Here we need to select which types of API we are going to create now: get method or post or fetch or put something. Here I'm selecting get, just for an example. I'm going to connect the Lambda function with the API, so it's default, it's selected, or else we can create something else. For now, Lambda function, and we need to select the Lambda function here. The Lambda function I created is this one, selecting this one, and after that leaving it as default and create method. Here now the API gateway is setting up. Once this is done, we can deploy it. By clicking deploy button we can deploy it. New stage, and we can give a stage name as test3 and deploy it. When deploying, it will give a gateway URL. This is the invoke URL. By this URL we can call this API gateway. It means this API gateway means this API gateway is connected with the my Lambda function. So directly by calling this URL, it will call the Lambda function. So get method, so we can call it using Postman for the testing, or else in the browser also we can do. Yeah, you can see the response text that we have written in the Lambda function is shown here. Lambda, this is the thing we have written, you can remember. Yes, I can show it. Yeah, this is the written message I have developed. If we doing any changes after doing, we need to deploy it, then only we can see the output. So that's all about the Lambda. Inside this Lambda we can do any kind of implementation. We can import libraries as well, and we can do our codings. And this is the test application we have created to show a demo of file upload and generate SVG and thumbnail and store them in S3 bucket and fetch using CloudFront URL. So these things will be done entirely using AWS Lambda and API Gateway and socket connection. Let's try to upload a large size of file with 16 pages, and you can see the process. Now I'm selecting the file. Yeah, now the upload is started. Now the file is uploading to S3 bucket, and the progress notification is showing using the AWS socket gateway. And yeah, the progress message you can see in the right top corner. After the file upload has been done, that will trigger Lambda function to generate SVG and thumbnail images, and it will store in the database. And after all the things are done, it will fetch all the thumbnails to the UI. After it has completed, you can see the output. Yeah, this is the output you can see. There will be 16 pages each page. For each page, the thumbnail and SVG has been created. Now you can see it only took around less than 1 minute. The same process, it took more than 2-3 minutes when we are doing the things entirely in the client side. Now we able to reduce all the time. Yeah, this is how we can give a solution for the defined problem using AWS services that is more scalable, efficient, and cost effective. Like this, we able to implement a unique and efficient solution for real world problems using this kind of microservices. So this is the end of this session. Thank you all for listening, and thank you Team Efito for this great opportunity.
Okay, Asluf, thank you for your session as well. I think that will be most helpful for everyone who is in our company as well. And I think we will all need to know about the AWS services further as well. So thank you for your session and hope the team will get some valuable knowledge through that. Okay, I think we will wrap the session for today and we will see you in our next session in next 2 weeks. Okay, good night.
Good night.